Hello everyone, and welcome again to our lecture. This is lecture 5, and we look at factors that affect strain gauge measurement. Factors affecting strain gauge measurement. Okay. Generally, when in use, strain gauges will be mounted on a specimen. Okay. This specimen could be a beam, for example, where we want to measure the stresses and the strains. Then there will be an area prepared, okay, for purposes of mounting the strain gauges, and this is where your strain gauge will be. So this is a strain gauge. Okay, so it's important to note that this strain gauge should be secured or fixed strongly to the specimen, okay, such that why is to ensure that there is a effective transmission between the two, that is between the specimen and the strain gauge, because what we are measuring with the strain gauge is the loading on the sample. Now when we talk about factors affecting strain gauge measurement, we are looking at every condition which is going to affect this assembly. It's like an assembly, okay, which will interfere with the readings of the strain gauge. Are we going to get accurate readings? So directly to those factors, and the first factor is sample preparation. Okay. Usually the surface. So if this is a cross section, and this is where the strain gauge will be. This is a strain gauge and this is a sample. Could be a beam. Now for this to adhere strongly, to have a strong bond between the strain gauge and the sample, the surface, this area here, this area must be clean. Okay, so ensure the surface is clean for the adhesive to stick and to work well, and dirt like oxides and paints are removed by use of a sandpaper. Okay, you can do sanding using silicon carbide grit papers. Okay, and usually up to 500 grit size it will be effective for this application. Then other greases, okay, oils should be removed with acetone, and then once sanding and acetone cleaning is done, finally we could use alcohol. Okay, then you can also rinse in water. Okay, also the surfaces of the strain gauge along the interfaces should also be clean. Be cleaned, and usually oxide, the greases or acetone be used to clean the backside of the strain gauge. Okay, so the second factor is the adhesives. Okay, and there are different types of adhesives which can be used to bond the strain gauge to the specimen. Okay, specimen. The examples are cellulose nitrate, epoxy, bakelite, cement, and so many. So this the most important aspect to note about the adhesives. The most important to note about the adhesive is any expansion or contraction of the adhesive during operation of the strain gauge is going to affect the readings of the strain gauge, and therefore should be avoided. That means when you are doing curing and drying of these adhesives, care should be taken such that a proper curing and drying is achieved. Okay. So the next factor is the strain gauge. The strain cycles. Okay. So usually for the first cycles, that is immediately the gauge is mounted and now it's loaded, or there is a application of load, the material or the alloy of the strain gauge is usually cold worked. Okay, cold worked, and issues of hysteresis occur. Okay, so that the readings obtained at these first cycles will be wrong, will be erroneous. Okay. The other important factor to note is the cold working. Okay, cold working and hysteresis will affect the change in the resistivity of the gauge alloy, and the hysteresis, which is like the system remembers the previous conditions, causes deviation in the linear relationship between the gauge output and the applied strains. Again, after so many cycles, which will be millions of cycles, the gauge may fail due to fatigue. Okay, and then again in this case there will be erroneous readings. So in between the first cycle and the so many cycles, there will be the region at which the strain gauge is stable. Okay, to give you the accurate readings. Okay, next is before is the heat dissipation. Okay. Obviously, we know temperature variation on the strain gauge affects the strain gauge readings. Okay, due to the expansion caused on the material. Expansion or contraction caused on the material. Okay, do you know the temperature depends on the atmospheric temperature and the heat generated in the circuit, in the strain gauge circuit. Okay, and this power, which the heat in form of power, is given by this relationship, which might be familiar. Then from here is what we call the power density. The power density is given by this power divided by the area of the grid. Okay, the area of the grid of the strain gauge, this area. That tells you the temperature, the heat dissipation of the power will greatly influence the strain gauge readings. Okay. Next is number 5 is a moisture and humidity. These two parameters affect the strain gauge reading in the sense that if moisture comes into contact, so if this is the adhesion between the strain gauge and the sample, so called this is a beam, this is a strain gauge. Okay, so if the moisture penetrates the adhesive, that adhesive is going to expand and therefore affecting the reading. Again, the moisture, once the moisture penetrates and there is the electrical current, especially in the Wheatstone bridge circuit, there will be the current. That current will cause electrolysis. Okay, electrolysis, and as we know, electrolysis will lead to erosion of the gauge wire or the gauge filament. Okay, so next is number 6. Number 6 is the introstatic pressure. Okay, and in applications such as in pressure vessels. Okay, pressure vessels, the pressure will produce a small change in resistance of the gauge. Okay, the gauge, which will also change due to the change in the resistivity. Okay, which is caused by change in this pressure of the vessel. So any change in resistance of the gauge results to change, affects the readings. Okay. Then number 7 is a magnetic field. If a strain gauge is being used in conditions of high magnetic fields, like electrical equipment which are rotating in high magnetic field, there will be the Faraday's condition or the Faraday's law. Okay, says that if this coil rotates and cuts the magnetic flux, there will be EMF generated and therefore current will be generated. Okay, and this will affect the readings of the strain gauge. Finally, number 8, the time. Okay, sometimes in some applications such as a railway or bridge structures, we might require several years to monitor, okay, their performance. What that means is a strain gauge will be mounted to stay for so many years on those conditions, and during that time it will be affected by the all above conditions. Okay, so the longer the strain gauge is staying in the measurement process, the higher the chances of getting erroneous values. However, there are ways to mitigate the effect of time on strain gauges. So that is the end of this lecture. Thank you very much.